Welcome back. I'm sure you enjoyed that break. Now let's get into the IDE. I'll show you to write those functions and verify that with the logic analyzer in the output. So I'll minimize this for a start, and I opened the IDE already. Stop where we left. Okay. Target disconnected. Yeah, that's okay. So I'll go and copy this and make a new project. So it'll ask for that. I will say we are on day 25 I2C part 3 slash ADXL 345, so we know. So copy and copied across. So I will minimize this and close this previously open file. So we are on day 25. We are going to concentrate only this. So source main C. Open the main C. So we already written the initialization code and the byte read, and today in this session we're going to write the burst read and burst write and interfacing with ADXL 345. Okay, so I'll copy this. First we're going to write for burst read. Probably I will change this to, oh sorry, I will exit so you can view the full screen. Burst read. You're going to send the address to slave address, then memory address, and then you need to send it with the n bit registers. So yeah, and then the character data. So you declared the function, as you know. Control C, you're going to write the function in here. Open, close. I'll start with, you need that int temp, so I'll just copy from here the dummy variable, paste it here, and then the first step will be you need to wait until bus is not busy. So the first step is same as this, so I'll copy this first step and paste it here. So that's the first step. We are waiting. And then the next step is you need to generate the start condition again. So generate the start condition, which can copy it from here and paste it here. So that's generate. Almost the first few steps are the same, so that's why I'm just copying to make it easier and faster. And wait until the start flag is set. Wait until the start flag is set. So that's the third step again. Got to go here and paste it. And after you set the start flag, then you need to transmit the slave address by writing 0. So you need to transmit the slave address. Copy this, paste it here, indentate, and then the next step, you got to wait until the address flag is set. So the next step is also the same. Wait until the address flag is set. Not responding, just wait for a moment. Okay, address flag is set. And the next step, after you set the address flag, now you need to clear the address flag through the dummy variable. So that's why we created the dummy variable. So you need to clear the address flag. Copy this and I will use this same. And then the next step, you need to wait until the transmitter is empty. You got to use this again until the transmitter is empty. That's the next step. And after the transmitter is empty, check, wait for it to be empty. Then you need to send the memory address. So copy the memory address from txt. Send the memory address. Oh, it's not responding. Come on. Okay, send memory address. Copy this. So this is where a small change now. After this, you need to send the memory address. And after the memory address, you got to generate the restart, which will be, you can use copy the restart from here, which is cr1 underscore start, and wait until the transmitter is empty. Okay, we need to use this, wait the transmitter is empty again. After sending the memory address, transmitter is empty. Then once the transmitter is empty, then wait until the start flag is set. So wait until the start flag, which is this one, SR1. Generate the start condition, this one, I2C. After transmitter is empty, you need to generate the start condition again. Generate the start condition. Then after the start condition, wait until the address flag is set. So again you have to wait until the address flag is set. So use that. These are all the protocols that you have to use, otherwise these are all the standard protocols when you use I2C. So that's why you need to be careful with all these steps. So in case if you miss any step, it may not be possible to do the data read. So next you're going to, flag is set, wait until the address flag. Next, clear the address flag through the dummy variable. So that's why we cleared this, used the dummy variable. So copy and paste that temp value. Okay, and the next step, here we disable the acknowledgement. Remember, here we disabled, here is this change. So now we need to enable the acknowledgement for the burst read. Enable the acknowledgement. Okay, to do that you need to link I2C one with the control register one by simply Ring with the acknowledgement. Yeah, and then if it is, we are sending n bit, so If it is 0 or any other value, then do this. If n is 1, then use this. If n is 1, first step is to generate the stop bit. Generate the stop. Generate the stop. And then once the stop is there, you got to link that with I2C1 with the control register 1 bit, and then you got to link with stop. Then wait until RxNE flag is set. So to do that, you need to put a small while loop of not equal to I2C1 linking with status register 1, and you just ANDing that with the RxNE is R1 RxNE flag. Then wait for it to set, and the next step is to read data from the data register. Read data from the data register. How are you going to do? You're going to do it with the data pointer. I2C1, sorry, should be I2C1 data register, and then break it. And then if it is not 1, then else. Wait until RxNE flag is set. So I'll copy this line and I'll just paste it. Copy. Yeah, wait until that, then read the data from the data register. I'll copy this line. Okay, so that's the else statement. Data register, then start to decrement the n bit. Yeah, and else closed. If closed, while closed, and the program is completed. So I'll just quickly save and check for errors in case if there is any before going into writing burst. Right, build the project. So this will also give the possibility now to generate the .elf file, which is very necessary. You need to load that to your register, to your microcontroller. So this is really needed. Still building the project. So the ELF file is generated. So 0 errors. That's what we are concerned and worried. So that's good. So we are on the right track. So now we're going to learn to write the burst write now. So the next function we're going to learn is burst write. So I will go and copy this again, copy, this time it's a burst right, so I will change this to, instead of read it's a write. And what you're going to send us the arguments, so character, yes, address, char memory address, comma int n, comma character data. So I just simply copy this, and you're going to write the function now. Okay, first we need to start with the volatile int temp, so we need this, copy this, now let's start writing the steps. The first step is wait until bus is not busy, so we need this, that's the first step. Copy this, paste it here, first step. And then generate the start condition. The second step is generate the start condition, which is this. I'll copy again and paste it here. And the next step, after generate the start condition, wait until the start flag is set. Wait until the start flag is set, which is the same. I'll copy and paste it here. Wait until the start flag is set. Then after the start flag is set, you need to transmit the slave address and write it. Transmit the slave address to write it. And after you write, you got to wait until the address flag is set. You got to wait until the address flag is set. So copy this and use it here. Yeah, wait until the address flag is set. Then the next step is clear the address flag. Once it's set, then clear the address flag with the dummy variable. So copy this, come here and paste it. Then after this step, you got to wait until the transmitter is empty. You got to wait until the transmitter is empty. Transmitter is empty, and then you need to send the memory address. You need to send memory address. So once the memory address is sent, then this is where the first a small change. So you need to generate a for loop with some iterations. So I is 0, I less than n, I plus plus. You have to write the for loop. Wait until the transmitter is empty. Wait until the transmitter is empty. So we need this, paste it here. Transmitter is empty. Yeah, and after it's empty, then write the data to the data register. Now you're going to write the data to the data register by linking with I2C1 of data register to the data pointer. Small data pointer increment. So the for loop finishes there, and after the for loop you need to generate the stop after the data received. After this step you need to write the stop, generate stop after receive. So this is where you need to use the byte transfer by putting it inside a simple while loop of not equal to, linking with I2C1 with the status register 1, and you just simply ending that register with the byte transfer SR1 underscore BTF, and wait until the generation finishes, then generate stop. Generate stop. That will be I2C1 of control register 1. You need to just simply R that with the stop with CR1 underscore stop. CR1 underscore stop. Okay, so now the burst read is done. Save. I will run another check to see for any errors, check for any errors, and then we will interface with the ADXL345. Build the project. Two errors with far burst right. That's a far. Subdirectory error 1. Build might be incomplete. I is not declared. Sorry. It should be int I equals 0, then I less than n, then I plus plus. Right click, build the project to check for errors. That's the initialization error. It seems to be happy now. Then we'll go and write the functions for the ADXL interface functions. Okay, so far so good, I think. Yes. Yeah, it's good. So now let's go and write the function for the ADXL interface. So void ADXL, first it's a read value, then the read address. So first the read values, and the argument is, it's an 8-bit uint 8_t for the reg, and then the second function you're going to read is to read the address ADXL read address of uint 8-bit t of register, and then you're going to write to the ADXL underscore write of uint 8_t and reg. Where are you going to write with? You're going to write with the character value. And then you need to write another program for ADXL init. So we declared all the functions. Okay, because we using a few extra variables here, we got to go and declare that, otherwise it will show some error. So I will go and define those variables below here, below this ADXL345 variables. First variable is uint 8_t. You're going to use this data receive of 6. So this 6 is nothing but x0, x1, all the three axes, x0, x1, y0, y1, z0, z1. Then int 16 underscore t, you're going to link that with x, y, and z axis. Then you need to include float values of x, g, comma yg, comma zg. Then enable the char data. Okay, now let's go and write every function that we just generated here. So first off, we will write with the init. So we're going to write the initialization. We're going to call the I2C1 init here, init first. That's the first step. Then you're going to read the ADXL values, ADXL underscore read. You need to call that function as well, read address first. linking with device ID register, and then you need ADXL write. You're going to set the data format register and the measurement of range 4_G. Then you're going to reset all the bits. So ADXL underscore write, and to set to the power control register, and then reset it. Then you need to measure it. ADXL underscore write, power underscore control underscore register, and then you need to set measure that value. Okay, so that's all we need to write in this initialization. I'll just simply so that is happy. So now we'll go and do the write. That's the init, it's good. So now we'll copy the write. So to write to the value, you need to set the car data. You're going to write only one time. So one value, and the data of 0, the first value would be the value. So we declared this above, so it won't show any problem. So link that with I2C1 with burst write. This is, we are just simply mapping to the accelerometer. So that's what we are doing with the device address, comma register, comma 1, and the data link. So that's the write function. Then we're going to do the read address and read value. So copy this. In the read address, you need to just simply link that to the byte read. Byte read of, then link that with the device address, then with the register and with the data. Yeah, and then finally the read values. So the read values is connected to the burst read, I2C1 underscore burst read. You need to link that with the device address with the register and with the 6 data, x0, x1, y0, y1, z0, z1, and with the character data. Care of data received. So this is x0, x1, y0, y1, z0, z1. That's what we are doing here. And I think we finished the program, but I will make cut this here, then cut this so to be have a uniform declaration. Should be uint. Okay, so this should do. So I'll go and save the program and check for errors. Right click, build the project. Oh, the same, because I just copied. Okay. Cortex, uint. Yeah. Save and then run. Okay, we are writing into the ADXL write. Yeah, ADXL write, uint reg character value, uint character value. We have given us the character data of 1, data of 0 is value, I2C1 of burst write, it's the slave address, device address, comma register, comma 1 and data. So this is not happy with the burst write link. Character is different to argument. Okay, I'll check the program. 1 sec. Read values, character deceive. The write should be data, burst write, device address, reg1 and data. Okay, so that's one error, and data format R4G. So that's the problem, it's not linking, so I had to check. Okay, I think I'll give you a short break. So once you come back, I'll start from here, and I will show you the output on the logic analyzer. So go and enjoy that break. I'll catch you shortly in a tick.